Alright, 7.9, square root functions and inequalities. Students will be able to graph and analyze square root functions and square root inequalities. Okay, what's important to understand is that the square root function, which looks a little bit like this, is really just an inverse of the parabola. So let's start with g of x equals x squared. Change that to y equals x squared. Switch the x and the y. And then if we were to solve, we would take the square root, take the square root. I'm going to work over here. We would get a plus or minus square root x equals y. Well, this graph here is the positive square root of x. And if I was to add in the negative square root of x, it looks something like this. Okay, so that's just the inverse of our normal parabola. Okay, so how do we graph something like this? Well, the very first thing we do when we get an equation like this is we want to figure out the domain. And we do that by saying, you know what can this not be? Well, we can't really have a negative underneath here. I mean, we know imaginary numbers can be underneath there, but we can't graph imaginary numbers. So when would this stop working? Well, it's whenever 3x plus 4 is no longer greater than or equal to 0, right? So we're going to set it greater than or equal to 0 and find all the values of x for which this works. So we subtract 4, you get 3x is greater than or equal to negative 4, divide by 3, divide by 3, and so you have x is greater than or equal to negative 4/3. That is actually your domain. X is greater than or equal to negative 4/3. Now, in this situation, we could also find our y-intercept, or I'm sorry, our x-intercept by plugging a 0 in for y. Well, if we were to do that, 0 would equal the square root of 3x plus 4. If we were to square both sides to get rid of the square root sign, we would just get 0 squared, which is just 0 equals 3x plus 4. So we'd get 0 equals 3x plus 4. We'd get the same equation here, just an equal sign. So in this situation, our x-intercept is actually also negative 4/3. So I could fill that in down here. Now what about the y-intercept? Well, we're going to find that pretty quick here because we're going to make a t-chart. I got my x's, I got my y's, and I know that my function starts at negative 4/3. So I'm just going to put in negative 4/3 here, and I'm just going to do integer values that are greater than negative 4/3. Well, the next one would just be negative 1, then 0, then 1, then 2, then 3, and I could go on and on and on. And so now I'm just going to plug these numbers into this function and write down what I get out of them here. And then here will be my y-intercept. The number I get out here will be my y-intercept because my y-intercept is always when x equals 0. So I'll let you guys go ahead and do that. Plug these numbers in, see what they kick out. I'll fill in the table here in just a second, so you may want to pause the video now. Okay, I filled in the chart. Here's what I got out. I approximated these radicals using a method that I taught in Chapter 5, so you can go look at those notes in Chapter 5, see if you can figure out how to approximate or estimate square roots. And yeah, now I'm ready to plug some stuff into my graph. So I got this t-chart, let's plug it in. I could also write down what my y-intercept is. I know that my y-intercept is 2. So let's just graph these things. At negative 4/3, I'm right here at about 0. At negative 1, I'm at 1. At 0, I'm at 2. At 1, I'm at about 2 3/5. At 2, I'm about just a little bit over 3. And at 3, I'm about 3 1/2, 3 4/7. And so now I can kind of see what's happening to my graph. And there we go. I've graphed that function. Last thing they want to know is they want to know what the range is. Well, take a look at the range. The range is all your y values. Where does it start? Looks like it starts at 0 and it just goes up. Slowly up, but it keeps going up. So that just means that your range is going to be all your y values that are greater than or equal to 0. Okay, let's go to the next page. Alright, a lookout on a submarine is h feet above the surface of the water. The greatest distance d in miles that the lookout can see on a clear day is given by the square root of the quantity h multiplied by 3 over 2. Okay, they want us to graph this function. Well, we don't even have a function yet. Let's write out a function then, okay? Well, what did they tell us? The greatest distance d in miles that the lookout can see on a clear day is given by the square root of the quantity, so that means we're going to take the square root of two things here, quantity of h multiplied by 3 over 2. Alright, so h is kind of like our x and d is kind of like our y. In fact, we can even put that on our graph here, h and d. That's how we're going to do it. So we're going to graph this function and then state the domain and range. Again, guys, you're going to take this value, set it greater than or equal to 0, solve for h, that's your domain. Make a t-chart, just graph this thing, and then you'll be ready to graph it. I'm gonna let you guys do that on your own. We'll do the same thing we just did before, where you take h, it's multiplied by 3 over 2, and you're gonna set it greater than or equal to 0 to find your domain. Once you find that, you know where to start on your t-chart for x and y. So yeah, I'm just gonna let you guys do that one on your own, and I'll fill it in a second, so you may want to go ahead and pause the video now. Okay, when you solve for the domain, you should have got that h is greater than 0, which makes sense, right? We can't be looking farther, we can't be looking, any distance if we're not above the water, right? So when our height is 0, if we have a periscope or something sticking out of the water at 0 feet, right, we can't see anywhere. Okay, so 0 to 0, and then these are the numbers that I got. I can estimate some of these. I can estimate the 3. This is going to be approximately like 1 2/3, and this one is going to be approximately 2 2/5, just to give us an idea of where to graph this thing at. So let's plot these points. 0 0 right there at the origin. 1 3 in red. 2, I don't even really know what that is, so I'm just going to skip it and just go straight to 2 and 1 and like 2/3, and then skip the next one and go 4 to like 2 and 2/5, and then go down to 6, which I know is right at 3. And there we go. Now I got a graph. Okay. Now, last question here is, if a ship is 3 miles from a submarine, how high would the submarine have to raise its periscope in order to see the ship? Well, look, we already have a distance of 3 here in our range, so that means that in order to see 3 miles, we'd have to have our periscope up 6 feet. So you could write that out as a complete sentence. And also, I forgot to just state the range. If h has to be greater than 0, d is also greater than or equal to 0. So there's your domain and your range. Domain being h, range being d. I know that's a little confusing, but remember, domain always goes with your x values, which in this situation is h, and range always goes with your d values, which in this situation is your y. Or, sorry, range always goes with your y values, which in this situation is d. So our answer to this question is just 6 feet. So I would, you should write that as a complete sentence, but I'm going to move on for the sake of keeping this video short. Okay, for both of these ones, I'm going to tell you to go ahead and make your domain, find your domain, and make a t-chart, and just graph the lines. The only thing that you need to worry about here is that this one is going to be a solid line because it's greater than or equal to, and this one is going to be a dotted line. So just make your lines, and then I'll show you how to do the shading. Okay, so hopefully you filled out the t-charts and found the domain and range. Now let's talk about shading. So for this one, y is less than, so we're going to shade underneath. But we're not going to just shade everywhere underneath. We're going to shade directly underneath this line where it starts, okay? So this is where we're going to shade. We can't shade over here because this is not part of our domain. And then same thing over here on this one. After you've graphed it, you should have gotten this t-chart. But y is greater than here, so we're going to shade above, again though, only where our graph starts and over. So I shaded a little bit over here and I shouldn't have, but it should be straight up from where we started. Okay, and that's it for 7-9.